fifth graders. Today we're going to talk about comparing fractions. And you're going to be seeing your greater than, less than, equal to signs a lot today. So just a quick refresher, with the greater than, less than, equal to signs, you always want the bigger side to eat the bigger number, kind of like we've said before with the alligator mouth. So just a quick little reminder with some whole numbers here before we jump into fractions. 456 to 546. I'd start in my hundredths place. I always start in my greatest place value. And I know that 500 is greater than 400. I don't even need to go any further. And so the bigger, I always say the alligator's mouth eats the bigger number. Another way to remember it that I think is really cool is you put the 2 dots next to the bigger number, 1 dot next to the smaller number, and then you know which direction it faces. So either way. So now what we're going to do is we're going to apply this to our knowledge of fractions. Same idea, your numbers are going to just look a little bit different. All right, so I'm going to go over a few different ways that we could compare fractions. When the numerators are different, but the denominators are the same, it's pretty straightforward. I can always draw my diagram here if I want to see it visually. So again, if I'm splitting it into fifths, I need 4 lines. You always need 1 less line. 1, 2, 3, 4. And then I'm actually going to draw 2 of them on top of each other to compare. And I can just bring my line straight down here because we're both working in fifths. Common denominator, pretty straightforward. 3/5 is going to be less than 4/5. If my pieces are the same size, my denominator is the same, my pieces are the same size, whichever one has more will be greater. So it's pretty easy to do that. I could almost do this without even looking at a diagram here. So I'll give you one more example. Let's say I had 2/6 and 4/6. Well, if they're both sixths, the pieces are the same size, I can just compare them directly. So if my pieces are the same size, 4 is greater than 2. So the common denominator, it's pretty straightforward, but we're going to start getting into some unlike denominators today. So I want to give you a new example here. We're going to start stepping it up a little bit, and you'll notice here, I can't compare fifths and sevenths directly with the denominators. They're different size pieces. Fifths will be a little bit bigger, sevenths will be a little bit smaller. So a good way to do this, I could look at my numerator. I have 2/5 and 2/7. If my numerator is the same, I can compare them. I know that fifths are bigger than sevenths. One way to think of this is, would you get more if 5 people are sharing a pizza? Or would you get more if 7 people are sharing a pizza? Obviously, with 5 people sharing, your pieces will be bigger. So 2/5 will be bigger than 2/7. So if I was to draw 2 diagrams here, 1, 2, 3, 4, there's my fifths, and then 1, 2, these aren't exact, 1, 2, 3, 4, 5, about that for sevenths. Here's my 2/5, and then here's my 2/7. The pieces are smaller, so whenever the denominator is the same, you can compare them directly using the denominator or using the numerator. Whenever the numerator is the same, your top number is the same, look to your bottom one. Which one's bigger pieces? I'll give you one more example of this. You could do this with unit fractions especially, 1/2 and 1/3. Would you rather have 1/2 of a pizza or 1/3 of a pizza? The numerator is the same. I know that half pieces are bigger than third pieces. So that's one way you can do it when your numerators are the same. But we're going to start seeing it get a little bit trickier. What if I do not have the same numerator or denominator? Well, I can't compare the size of pieces. I can't compare the number of pieces. They are completely different. One way I can compare unlike fractions is I can use multiplication. And we've been working on this. So I could say, all right, I want to turn my 3/4 into eighths. Then I can compare my pieces directly. So I know that I want to turn it into eighths. Well, I know that 4 times 2 is 8. Whatever I do to the denominator, I have to do to the numerator. So then 3 times 2 is 6. So 3/4 is actually 6/8. So it's funny, if you look at this, immediately off the bat, you might think, okay, well, 3 is smaller than 5, 4 is smaller than 8. Obviously, this is the bigger fraction. But when you find this common denominator using multiplication, you'll see that 3/4 is actually 6/8. It's actually bigger. You could verify this and double check if you wanted to draw a diagram, a tape diagram. I have my 3/4. I'm gonna actually carry these down to make my eighths because I'm splitting them again. So here's my 3/4. If you ever want to double check with a picture, that's always a good idea. And then here's my 5/8. 1, 2, 3, 4, 5. So you can actually see here that 5/8 is less than 3/4. But a good way to do this is with this multiplier. This is what we've been working on. So it's easy to multiply, find a common denominator, and then you can compare. Let's do another example of that one. So I'm going to use 2/5 and 6/10. Again, no common numerator, no common denominator, but I know I can turn my fifths into tenths with multiplication. So I'm going to take my fifths, and I like to set it up with this empty multiplier like that. It's kind of up to you guys, but for me, it really helps me see, helps me see across a little bit better and kind of visualize it. So I know that 5 goes into 2 times. Whatever I do to the bottom, I have to do to the top. Oh, it's actually 4/10. Well, now I can compare them because they're both in tenths. 6/10 is greater than 4/10. So you can multiply like that to find a common denominator to make it easier to compare. Another way I can think about this is with our unit fractions. Our unit fractions are big, easy fractions that we can work with, that we're comfortable with. They're single units, 1, 0. So you can use these unit fractions. Usually comparing it to 1/2, I feel like, is the easiest way. So I can think about a number line in my head, right? Or you could draw it if you need to. If I think about a number line in my head, and I'm just going to kind of estimate with my unit fractions here. I know that 5/10 is 1/2. So this will be a little bit somewhere over here past 1/2-ish. And I think about 5, half of it would be about 2.5. So it's a little bit less than 1/2. So I think about this mental number line, comparing it to 1/2, I know that 6/10 would be greater. So you can kind of make a visual number line in your head, or even draw your number line if that helps. So let's do another one. I'm going to do 2/7 and let's say 8/9. Well, I don't have a common numerator. I don't have a common denominator. I need to think through how I could compare this. So one way I could do it is compare it to my unit fractions. Again, mentally or draw it out. I like to do 0, 1/2, and 1/2. I think that's the easiest for me. You can get more detailed if you like. I know that 2/7 isn't very big. I know that 7/7 is 1 whole. I know 2/7 will be somewhere right in here-ish. It doesn't matter exactly. But my 8/9, I'm only 1/9 away from a whole. I'm really close to a whole over here. So if I compare it to my unit fractions, I know that 8/9 is only one little jump away from a whole, and 2/7 is way far away. So I know that my 8/9 would be greater. But what if we had two fractions that were both pretty close to a whole? Well, I'm going to have 5, 6, and 9/10. I could say, let's find a common denominator. I can multiply this by 10, multiply this by 6. Now we're working in 60ths, and it's just really big and confusing. I would say, let's think about our pieces size. Let's compare it to a whole. If I think I am one piece away from a whole here, and I'm one piece away from a whole here, great, they're equal. That's what we think sometimes, but that's not true. They're both one piece away from the whole, but they're very different piece sizes. So if I was to draw this on a number line, and I'm going to do two number lines next to each other, kind of think of two tape diagrams next to each other, 0 and 1, and then I always put my 1/2 just to kind of keep myself centered here. So if I was to split this into 6ths and 10ths, so I would have right here, 1 6, 2 6, 3 6, 4 6, 5 6. Great, it is definitely close to a whole. So, but now I need to do my 10ths. So I'm going to split it into 10ths. 1, 2, let's spread these out a little bit more. 3, 4, 1, 2, 3, 4. And again, they're not going to be quite exact. But you notice my 10ths pieces are smaller. These little pieces are smaller here. So I'm one small piece away from a whole versus one little bit bigger piece away from a whole. And again, you can think about this with a pizza. If I split a pizza into 6, let's see here. 6ths. Each piece is worth a little bit more. This piece is a little bit bigger than if I was to split it into 10ths. This one's tricky. 1, 2, 3. That's only 8ths. We'll go this way and this way. These pieces are a little bit smaller. Bear with me on my drawing here. So 5 of these is further away from a whole than 1, 2, 3, 4, 5, 6, 7, 8, 9 of those. I only have this little piece missing. So 9/10 would be greater than 5/6. So you can always think about the size of the pieces when it comes to this as well. So I want to look at a couple of our problems that we're going to be focusing on today. So here we have 7/8 and 8/9. This is what we were just talking about. I know that my 7/8 is 1/8 away from a whole. I'm 1/8 away. So I'm just going to write that down here. I'm missing an 1/8. Over here, I'm missing 1/9. Well, 1/8 is going to put me further away from a whole than 1/9 because it's a bigger piece. So I know that 8/9 would be bigger than 7/8. Another one, if we look at 2/3 versus 3/7, well, 2/3 I know is greater than 1/2. And 3/7 is less than 1/2. So I could use that strategy real quick to go on this one. And let's see, I'm going to pick one more. Let's go to 18. 7/12 and 1/3. That seems like a really easy one to find a common denominator because I know that 3 goes into 12. Some of these you guys are a little bit trickier, like eighths, sevenths, fifths, sixths. I'm not gonna find a common denominator on those because there just aren't friendly numbers. My common denominator would be way too big. So you'll see we're kind of using a different strategy for each one depending on which one fits best. If they are close to each other or they are a common denominator already, like I would just multiply. But if you're trying to compare fifths and ninths, maybe compare it to 1/2 because those are just going to be too hard. You don't want to turn them both into 40/5. So 3 goes into 12 4 times. I've got to do the same to my numerator. I'm now at 4/12. All right, well, I know that 7/12 is greater than 4/12. As you go through this, you will notice different strategies work better for different problems. And that's kind of the point of today, is really working through it and figuring it out. If, just a quick recap here, if the numerator is the same, like in number 21 here, 7/9 and 7/10, well, I know ninths are greater than tenths, I can easily do that. Or if I look at number 27, fifths go into tenths really easily. If I multiply by 2, I'm gonna just multiply there. So you kind of have to go through and figure out which strategy, or thirds and sixths at number 22. Those two go into each other easily. And then if not, you can either compare it to 1/2, or you can compare it to how far it is away from a whole. So again, number 24 here, 9/10 is 1/10 away. 8/9 is 1/9 away. I know that tenths are smaller than ninths, so it's going to be closer to a whole. And you guys can come back to this video to kind of help you guide through this today. But try out different strategies depending on which fractions you are comparing.